Okay, let's do a little review on radicals and exponents. Okay, so with fractional exponents, the number in the denominator, that is the power. And then the number in the denominator, that is the type of root. So it would be the cube root of 27, and then all of that is squared. So that would be 3 squared, which is 9. Okay, so then this one would be the fifth root of negative 32, and then we'll take and square all of that. So we would get negative 2, and that's squared, so the answer there is 4. All right, now we have a negative exponent, and what that does is it takes our base, that 4/9, and it flips it upside down. It's the reciprocal of the base, and then it's to the positive power. So notice we don't do reciprocal on the power itself, we just do reciprocal of the base. Okay, so then the taking something to the 1/2, that's the same thing as taking the square root. So then we can take the square root of each of those separately, and our final answer on this one is 3/2. All right, now on this next one, I've got negative exponents in both the in the base there, and then also on the outer exponent. I'm just going to deal with that one on the base, or the exponent first. Okay, so I'm going to take the reciprocal of this base to the positive power. So 32y to the 5/2, that goes up in the numerator now when I take the reciprocal. X to the 10th, y to the negative 5 goes in the denominator, and now I get to take that to the positive 1/5. Okay, so I dealt with my negative exponent, and now I'm going to work on taking everything to the 1/5 power. So I would take 32 to the 1/5 power. I would take y to the 5/2 to the 1/5 power. I would take x to the 10th to the 1/5 power, and y to the negative 5 to the 1/5 power. Okay, now a number to the 1/5 power, we can do the fifth root of 32, and then with our variables we can just multiply because we have something to a power, so that would just multiply those 5/10. This would be like x over 1, so it would be x to the 10/5, and y, oops, that's a 1 there, y to the negative 5 over 5, and then we can just simplify that. Fifth root of 32, that is 2, and that simplifies to y to the 1/2, x squared, y to the negative 1, and now I'm going to deal with my negative variable, and that just allows that y to the negative 1, it's going to move up into the numerator and be positive. And then I get to add my exponents there for the y's. Okay, so this would be 2 y to the 1/2 plus 1, that would be 3/2 all over x squared. And that one is now done. All right, in example 2, we have addition in both the numerator and then subtraction in the denominator. And so we're not able to just simply simplify like we did before. If it had been multiplication, we would just be able to move things around. X to the negative 2 would have come down into the denominator, x to the negative 1 would have come up to the numerator. So that's only if there's multiplication. This, it ends up being a complex fraction because of that addition and subtraction. Okay, so what I have here is x to the negative 2. So I'm just going to write that as its own little fraction, and then I have plus y to the negative 1, that would be 1 over y. Then x to the negative 1, that's 1 over x, and then y to the negative 1 is 1 over y. Okay, so I'm going to first rewrite them. Instead of negative exponents, I'm going to deal with all those negative exponents by writing them all as fractions. Now I'm going to multiply by the LCD. So that LCD would be x squared y, and that's what I'm going to multiply by. Okay, and then those are actually over 1. Great, and now we'll go ahead and distribute. So we've got 1 over x squared times x squared y, and then plus x squared y times 1 over y, and x squared y times 1 over x, and x squared y over 1 over y. Okay, and now we can simplify everything. Because I chose the LCD, every single place I have a fraction, it will simplify. So then this ends up being y plus x squared all over y. xy minus x squared. Okay, so that's our simplified expression, and then we need to do our domain restrictions. So x cannot equal 0. We're just looking for any place where there could be a 0 in a denominator. So right here, x cannot equal 0, and also in here, y cannot equal 0. And is there anything else? I think that's the main areas. Okay, so x cannot equal 0 and y cannot equal 0. All right, in this example, we're going to multiply. So we're going to distribute. We're going to take and multiply that x to the 1/8 times 3x to the 7/8. And we're also going to multiply it times x to the 3/8. And then we would have 3x to the 1/8 times x to the 7/8. We get to add exponents there. And then we'd have x to the 1/8 plus 3/8. So this would end up being 3x to the 8/8, which is just x to the 1, or just x, and then minus x to the 4/8, which is 1/2. Okay, in this example, we're going to factor with fractional and negative fractional exponents. Let me just remind you, factoring is the opposite of distributing. So if I had this example back in the day when this is all we had to factor, okay, I notice that there's an x common to every one, so I just factor it out, and I just, in my head, kind of think about, well, what would I have left? The actual process, what we're really doing is we're dividing everything by that x, and at the same time, then because we've divided everything, you can't just make everything smaller by dividing, so you're also multiplying by the same value. So we end up with an expression that's equivalent to what we used to have. And then once we've done that, we would just go ahead and factor what we have left. Okay, now notice that these exponents end up being, we took 3 minus 1. We would subtract those exponents, okay? So that's what factoring really means. So what we're going to do is we're going to, just like we did here, we found the smallest, we found the smallest x, not the x cubed. We didn't factor that out. We just did the smallest one. So we're going to do the same thing here. We're going to look to see, okay, which term has the x with the smallest exponent. Okay, what we're going to do officially is divide everything by that term. Okay, now that means that we're then factored out that term, okay? So, because what we're dividing by is a negative exponent, when we go to, here, I'll just copy that down. Okay, when we go to subtract our exponents here, right, to get that 3, or to get that 2, that was 3 minus 1. Okay, we're going to take what was in the top 3/2, subtracting that negative 1/2 from the bottom. We do the same thing here. We had 3x to the 1/2. Oops, that's a positive 1/2. 1/2 minus a negative 1/2 plus 2x to the negative 1/2 minus a negative 1/2. Now, because we're always subtracting minus a negative, that ends up being adding those exponents. So we've got x to the negative 1/2 x to the 3/2 plus 1/2 minus 3x to the 1/2 plus 1/2 plus 2x to the negative 1/2 plus 1/2. Okay, so a lot of people, what they'll do is they'll kind of just skip this step, factor out that negative. Because they're factoring out a negative, they know that they're subtracting a negative with their exponents. So then they can just kind of skip right ahead to that step right here where you're adding those 1/2, because that's what you'd factored out. Okay, so moving on, we've got x to the negative 1/2, and now x to the 3/2 plus 1/2, that would be 4/2, which is 2. X to the 1/2 plus 1/2, that would just be x to the 1, which is just x, and then plus 2x to the 0. X to the 0 is just 1, so that's 2 times 1, that would just be 2. Okay, now I have this negative exponent. Depending on the directions, sometimes it's fine to leave it with that negative. We'll just factor that out, but we can also write that with a positive exponent. And then x squared minus 3x plus 2, I think that'll factor minus 2x minus 1. And so then we could be left with x minus 2 times x minus 1 all over x to the 1/2. Now I think on some of the homework it will be okay just to leave it with this x to the negative 1/2. All right, let's try another one. All right, so I'm seeing negatives. And so what I do is I think, okay, who is smallest of you all? And it looks like negative 3/2. Okay, so that's the thing that I'm going to factor out. Whoops, out comes my x to the negative 3/2. Okay, so when I do that, I know I'm really dividing by that. So I take my original exponent. Since I'm dividing, it would be minus, but because it's negative, minus a negative is plus. There we go, plus 2x. We had originally a negative 1/2 exponent, so we'll add 3/2 because of what we factored out. 3/2, good. Okay, so x to the negative 3/2, that is 1 over x to the 3/2. X to the negative 3/2 plus 3/2, that's just x to the 0, which is 1, plus 2, x to the 1/2, my plus 3/2 would be 2/2, which is just 1, and this would be 4/2, which is 2, and so then we've got, let's see, I'm going to put all this over x to the 3/2, and then I have x to the 0, which is 1, plus 2x plus x squared, and that will factor 1 plus x times 1 plus x, or x to the 3/2, and we could write that as 1 plus x, or x plus 1 quantity squared. And we're done. Okay, here's our last one. Let's see, I'm looking at the top and I'm seeing negative exponent, so I'm thinking, let's see, who has the smallest exponent, and it would be the negative 1/2. Okay, so my base, it doesn't matter what my base is, but out's going to come that base, in this case it's x plus 3, to the negative 1/2. Out that comes. Okay, and now I have taken getting x plus 3 to the original 1/2. I'm factoring it out, so that's really dividing by that x plus 3 to the negative 1/2. So when you divide, you subtract a negative exponent, so we get to add that exponent. Okay, now we had x plus 3 to the negative 1/2 plus 1/2. All I'm doing is factoring out that negative exponent in the top. I'm not going to mess with my denominator yet. Okay, so now this is negative, So I'm going to go ahead and just bring that down to the denominator right now. So I've got x plus 3 to the now positive 1/2 times the x plus 3 that was already down there. Okay, now I have x plus 3 right here. 1/2 plus 1/2 would just be the 1 exponent, and then minus x plus 3 to the 0, negative 1/2 plus 1/2. So x plus 3 to the 1, that doesn't even need to have an exponent or parentheses. Anything to the 0 is just 1. And now I get to add my exponents here. So I would have x plus 3 to the 5/2. And then just clean that up a little bit. X plus 2 in the top, x plus 3 to the 5/2.